So tonight we will study one more distribution. We call this F distribution, or you can say F test. So it's another hypothesis test that we have done similarly here. So what is the F distribution, right? It seems not a good word, is it right? So give you an idea of what's the F distribution. We call what is the T distribution, right? So, I mean, actually we should start from the Z distribution, which is a bell-shaped curve, right? Now, in terms of T distribution, is also the bell-shaped form. You have different degree of freedom, then you have different kind of curve, right? Can be negative, can be positive. And the degree of freedom, we are using the formula n-1, right? So that's the one you see that here for the T distribution. Now for the chi-square distribution, which we learned last week. So this case here is a very special case that you can see it is a bell-shaped form, but it's not symmetric, right? It's like a skewed to the, this side is to the left, is that right? And then we study this chi-square distribution because of what? Because of this S square. In other words, we are trying to study the sample variance. We realize that the sample variance, when we put it into that format, they follow this distribution called chi-square distribution, right? The very special part here, you see, you only take positive value. There's no negative value here. Why? Because in the formula, if you see this in the formula, you have n-1. Sample size -1 usually positive, S square positive, sigma square even more positive. So in other words, all the parts here should be positive. So that's the reason we only got a positive value for chi-square distribution, right? Degree of freedom, the formula we are using n-1. Now what's happening for F distribution here, right? It's very similar. It's very similar in terms of you only got a positive value here, right? And if we are asking ourselves, why we are trying to study this F distribution, right? So it's essentially we are trying to compare two variance, two sample variance. So previously, when we study chi-square distribution, we are trying to study one sample variance. Now when we are trying to compare two sample variance, everybody, which is very straightforward here, the formula is what? Is the ratio of those two variance. S1 square divided by S2 square, right? If it's bigger than 1, then we know S1 square bigger than S2, like that. So in other words, F distribution is trying to study those two variants here, which one is bigger, right? The very special part here in terms of degree of freedom. So you have two samples here, right? So you have N1, you have N2. So you have N1 minus 1, N2 minus 1. Previously, if you remember, when you are using two sample case for the T distribution formula, right? We are using a minimum one, like N1 minus 1, N2 minus 1. Which one we are using? We are using the minimum one. But in this case here, we are trying to compare those two sample variants here. Which one is bigger? It's going to be a different formula here. We have N1 minus 1, N2 minus 1. We have to use both. We will come to later, how do we use this degree of freedom here, everybody? So this is to give you an idea of what is the F distribution look like, right? Okay, so now we understand F test, F distribution is to compare two variants. That's the first application, everybody, for the F test, to compare two variants. So you can see that the formula here, two variants. We are using some example here to help you understand better why we are studying that way. Say we want to do some medical research, whether the variance of the heart rates of those people who do the smoking, right, compare with the people not smoking. So we are trying to see their heart rate, the variance of the heart rate. How do we understand that, right? Intuitively, variance means what? Means the change to the average. So in other words, if we measure the people's heart rate, right? Unless if you are doing the exercise, right? Or sleeping, otherwise, most of the time, our heart rate should be relatively stable. Is that right? So, I mean, that's like intuitive understanding. So now what if some people, like you see that their heart rate sometimes high, sometimes low. In that case, the variance, the change is bigger. So in other words, what we are trying to do here is trying to see for the smokers and the non-smokers to see any significant change, right? For those smokers, non-smokers, any significant change or for their heart rate. For example, if we find out for smokers, right? Sometimes their heart rate is high, sometimes their heart rate is low. That means there are more change. In other words, the variance for the smoker is bigger. Then in that case, we say, oh, looks like smoker is not that good smoking. Is that right? So you see, that's the like one of the intuitive understanding why we want to do that, right? Intuitively, it's making sense. Is that clear, everybody? So that's the why we are doing this F test to compare those two sample variants, right? Intuitively, we want to compare those two groups of people, smoker, non-smoker, right? Their heart rate change. So now we randomly select the data. We got two samples. Smokers, we got how many? 26 people, right? Non-smokers, we got 18 people. So those information are given. Also, we are given what's the sample variance. The smokers, we got the sample variance 36. For the non-smokers, we got the sample variance 10, right? So what's our goal here? We are trying to see the first group, smokers, right? That sample variance 36. Is that statistically different from the non-smokers, right? From those 26 smokers and 18 non-smokers, we can clearly see the smokers here has a bigger variance because 36 is bigger than 10, right? So for those two groups of people, we can say smokers has a bigger variance. That's straightforward. The question here is, can we apply this to make a conclusion for all the smokers, all the non-smokers? Can we say that? Do we have 95% of confidence to say that? So that's the record confidence. That's the confidence coming, right? Now we are going to use the 5 steps hypothesis testing to do that. Everybody, right? You learned that before. I'm not going to repeat that. The step number 1. So we write down H0, H1. In this case here, we are trying to compare the group number 1, the sigma 1 square equal to sigma 2 square, right? Are they equal or significantly different? So I didn't say they are higher or lower here in the assumption, the question statement we are trying to make here, right? So in that case, sigma 1 square not equal to sigma 2 square, H1, 2 side, right? So that's step number 1. Step number 2, we always do the calculation first. Everybody, I want to follow the same order. I don't want you to get it confused, right? So F calculation for the F test is very straightforward. It's equal to the S1 square divided by S2 square. That's easy, straightforward. So S1 square is the group of smoker, 36, divided by group of non-smoker, which is 10. So we got 36 divided by 10, 3.6. That's the F statistics. From the calculation, we got that. Very easy, everybody, right? Now, step number 3, find out the critical value. Find out the critical value. If you remember, critical value is coming from where? Coming from a table, right? So it's coming from Z table, or coming from T table, or coming from F table here, everybody? Which formula, right, determined here, we are using F test. The formula here, you see, is F test formula. That means we are using F distribution table. Everybody, what is a F distribution table look like, right? We showed you before, what's the curve for the F distribution look like? We see that, right? Now for the table, what's that? Let me show you what's the F distribution table look like here. So this is like one of the examples I did Google, like F distribution table. This is one of them here, everybody. So you see that they have like DF1, DF2, right? That's like one way. There are so many different tables here. You see that. You Google F distribution table, give you quite a few different ones, right? So you have what's the DF1, what's the DF2, right? And you have the alpha equal to 10%. What's that mean, right? Similar that here, you have degree of freedom, the DF1. What we actually say degree of freedom in the numerator, everybody. Degree of freedom in the, you see that here, denominator. So in that case here, why we have denominator, why we have numerator? Because you see that is a ratio, right? So S1 square is in the numerator, everybody. That's in the numerator, which is corresponding to 36, right? This is a smokers. What's the sample size? 26, everybody. So 26 minus 1, that's the degree of freedom for the numerator. So in other words, if I have to use this table here, I have to use 26, everybody, degree of freedom, capital N for numerator. So it's 26 minus 1, which is give you 25. Think about that in this table here. This is only one table here, everybody. You only cover 1, 2, 3, 4 up to 9. How about 10, 11? You have to get another pages. Same as degree of freedom in the denominator, right? So it's N2 minus 1, which is 17. So in other words, you will have to find out like different pages. You see that here? It's going to be very, very complex, everybody. So in other words, for our final, for the coming exam number 4, we are not going to require you to use this table, F distribution table, to do any calculation using the F distribution table. Everybody, no worries for that. Unless you strongly request that, otherwise, we are not going to ask you using F distribution table to do any calculation, okay? There will be some other questions related with the F test, but not with the F distribution table, just to be clear. Okay, so in that case, we have degree of freedom for the numerator 25 and for the denominator 17. So just FYI, right, later on, I mean, not for our class. If you have to do that, you need to find out the corresponding degree of freedom here for the 17, and this one, 25, 20 something, right? Let me see, what's the number? It's 25, right? And then corresponding degree of freedom for the denominator, 17, right? Also, what's the alpha? Think about that. Alpha here we have, you see, that is, if you are looking at this table, DF1, DF2, right? You have the alpha is equal to 10%. In other words, 10% give you one page. How about 5% give you another page, right? 1% another page. You will see so many different pages. That's another reason we don't require using F distribution table to do any calculation. Okay, so in other words, we are not going to ask you to find out what's the critical value here. So from the table, we find out, well, that critical value, CV critical value is 2.56. Okay, now, so we have finished the calculation. We have found out what's the critical value. Step number 4, remember, try to make a decision. When you make a decision, remember, try to draw this bell-shaped form, right? The bell-shaped form here, alpha is 5%. Critical value is 2.56. So in other words, if I have to draw that here, let me see. If I have to draw, it's not a symmetric curve, right? It's not a symmetric curve. As you can only have positive value here, right? So what is our critical value here? 2.56. It's like here, 2.56. And then where's our test? Our data is somewhere here, everybody. 3.6. That's our data. You see that here? That's the F test, right? So our data tells us we are here. The critical value, you can imagine this is like a vertical bar here. You can put that, right? What's the center? The center is what? H0. Data tells us we are further away from the center. So what does that mean? We are going to reject HO. We are going to reject HO. What does that mean? We are going to accept H1. Why do we care about H1? H1 is the statement, right? So remember what our statement is trying to say here. Is there any significant difference, right? So what's our conclusion here? Yes, right? H1 is right. There's a significant difference between the group of smokers and the non-smokers. In terms of what? In terms of their variance of the heart rate. So in other words, the heart rate change. Somehow we can see the groups of smokers and the groups of non-smokers, there's a significant difference. So that might be an angle or hint to tell us smoking seems not that good. Everybody? So that's the practical reason why we are doing this study here, right? Everybody? So, so what's happening in reality is, I mean, if we want to study smokers, non-smokers, you can see that from all kinds of angles, right? Here is only one angle to see the heart rate change, right? Here we find out the heart rate change for the smokers is significantly different from the non-smokers, right? So, I mean, we are not really say that, I mean, non-smoker is not good. I mean, non-smoking, smoking is not good, right? But it provided one angle to see that smoking might not be that good, right? So in reality is people try to do that from different perspective, different angles, right? So this is only one angle. At the end, if there are several angles, several evidence pointing to smoking is not good, right? So that gives us kind of this conclusion, smoking is not that good, right? If they are all pointing to the same direction. That's the idea here. So far, so good. So that's our first application, everybody. In terms of using the F test to compare two sample variants. The second application here, what do we call, everybody? Analysis of variance. This is a very advanced concept. Analysis of variance, if you are going to study more statistics, right? There's actually one class. The title will be Analysis of Variance. You can easily find a book. The title is Analysis of Variance, right? Everybody, ANOVA, ANOVA stands for Analysis of Variance. So what we are trying to do the study here is the second application in terms of using the F test to compare multiple groups. Everybody, compare the 3 groups or more. Okay, so why we want to do study like that, right? Here is some example. This example here, we want to compare the blood pressure of 3 groups of people. The blood pressure change, you can understand that way, right? Three groups of people here. The first group is the people of doing the medication, right? So we have 1, 2, 3, 4, 5, 5 people. What we measure here is the blood pressure reduction, right? So that tells us the first person, right? Reduction 10, 20, 12, 9, and so on. The second group, 5 people, right? Different people, 5 people here. The reduction in terms of the blood pressure, right? They are doing by exercise. The third group of people, they are doing the diet, right? So in terms of the blood pressure reduction, it's those 5 numbers here. Everybody? So we understand we have 3 groups here. What's our goal here? Our goal here is try to compare those 3 groups, right? So 3 groups here. Can you see any significant one group different from the other 2 groups or from the rest of the groups, right? So in other words, we are trying to do the hypothesis testing, everybody, H0. That means everything is equal, remember, right? So we have 3 groups here. We can write down mu1 equal to mu2 equal to mu3, right? Now H1 here will be, as long as you find out one group average is different from the other, then that's good enough. Everybody? That's the second application, using F-test to compare multiple group average here. Okay, so how can we do that, everybody? The calculation is complex. We don't require you this calculation here. It's way more complex, but we want to introduce some concept, which is required for this class here. Everybody? So let me try to explain what's happening for the calculation here. The first group, we have 5 people, right? In other words, 5 numbers here. So we can calculate the average. So I'm using capital X1 bar, that's the average of the first group of people, right? 11.8, right? How many people? 5 people. S1 square, I can using the 5 numbers here. How do we calculate this variance here, right? We have that beautiful formula we learned previously, right? So we find out S1 square is 5.7, everybody. This is within the group variance. Is it right? It's like one group, 5 numbers. You do the average first, and then using that beautiful formula to calculate what's the sample variance here. Everybody, it's for this group. That's the reason we call this number here is within group variance. Follow me? Within group variance. Okay. Similarly, second group, we have the within group variance. Third group, right? Within group variance. That's easy. That's straightforward. Now, the special part is this one here. When we have this group between group variance, how do we calculate that? Between group variance here, the calculation, everybody, I don't require that, is to calculate that sample average here, right? 11.8. The difference from that one to the overall average. What's the overall average? This number here, you see? This number. That's the overall average, 7.73. So you are using the 11.8 minus 7.73 and square multiplied by 5 to find out what we call this between group variance. So in other words, for this case here, everybody, if you pay attention here, what's happening is we are trying to break the variance into 2 parts. The first part we call within group variance, right? Within group variance. So in other words, within each group, what's the variance? Within each group, what's the variance, right? So it's S1, S2, S3, within each group. The second part here is a between group variance. What does that mean? It's like when you compare this group to that group, what's the significant change, right? In this group to that group like that. You can understand that way. So everybody, we don't require the calculation part, okay? We don't require the calculation. okay? But we do require the concept. When we say within group variance, between group variance, this part here we do require, okay? Now, in terms of the example, right? When we do the calculation here, let me see. So what we find out here is we are using the, everybody, we are using the F-test here. You see that here is a ratio. It is still a ratio, everybody. So it's a ratio of MS over MSW, everybody. If that MS confuse you, that's okay. But make sure you understand what the B means here. B means between group. Remember, we have mentioned that here, the between group. And MSW is for within group. So that means square. So it's the mean square for the between group and then the mean square for within group. Everybody, right? So in terms of calculation, I don't require that. You don't have to do the calculation, but I do require the formula here, degree of freedom for the denominator and for the numerator. How do we calculate that, everybody? If you care about the final, pay attention to the rest of 2 minutes. Okay, degree of freedom for the numerator, right? This part here, degree of freedom n. This part here. So degree of freedom n, what's n here? Right, that's a between group, right? That's between group. Let's see. Where is the between group, right? So between group is here, everybody. What's the degree of freedom for this between group? How do we, which formula we should use, right? Degree of freedom for between groups, everybody. Think about how many groups we have. How many groups? We have 3 groups. That means the group of number is 3. 3 minus 1. What's the degree of freedom for between group? Is 2. 3 minus 1, 2. Everybody? Now, what's the degree of freedom for this degree of freedom denominator, right? What's the denominator here? Is the within group, right? So what's the degree of freedom for this within group? Let's go back to the table here, right? What's the degree of freedom for the within group, everybody? If you are familiar, if you remember this is one group. What's the degree of freedom? You have 5 samples here. Degree of freedom 5 minus 1, which is 4, right? Similarly, what's the degree of freedom for this case here? 4. What's the degree of freedom for this group here? 4. 4, 4, 4. What's the total? 12. Everybody? So the degree of freedom for within each group is what? Is 12. You see that here? We got 12. Okay? So there are 2 ways you can do the calculation to find out degree of freedom for the denominator. Denominator, which is for within group W. Okay? First way, you can calculate what's the degree of freedom for within each group. 4 here, right? 5 minus 1, 5 minus 1, 5 minus 1. Add them together, you got a 12. One way. Another way, how many total number of samples here we have? We have 15 altogether people here, is that right? 15 altogether people. Now, that's a total of 15 data points minus how many groups? 3 groups. So you also got 12, everybody. That's another way. So on the final, you will see some homework questions asking you to do what's the degree of freedom for the numerator? What's the degree of freedom for the denominator? Right? Numerator, one more time, it stands for B for between groups. The formula is number of groups minus 1. So if you can write down on your next notes, right, degree of freedom for the numerator is number of groups minus 1. Degree of freedom for the denominator within group is what? Is total number of points minus number of groups. That's the one you find out. So based on that, since I mentioned that earlier, we are not going to ask you to find out the critical value. So 3.89 say we are given that. Now, based on that information, which conclusion we should make here, right? So let's see. Critical value, 3.89, right? What's the data? Data tells us 9.17, which is further to the right, right? In other words, if you want me to draw the curve like that. I didn't draw very good. Let me erase that. So remember the F distribution is not a symmetric, right? It's not a symmetric, right? So critical value 3.89. That's our critical value here. Where's our data? Our data is 9 point, like way to the right, right? 9.17. Everybody? Data is further away from the center. What's the center? H0. Data is further away from H0 means what? We are not supporting H0. We are not supporting H0. We are supporting H1. Means what? There's a significant difference, right? At least one group is different from the other for those 3 groups of people. Is that clear, everybody? So that's the idea using the F test to compare multiple group average. Okay, multiple group average. So that's in terms of the 2 applications, everybody. Why we are using F test, right? So the first part, we can using F test to compare 2 variants. Straightforward, right? Ratio of 2 sample variants, right? Number 2, we can apply the F test for multiple group average, like mu1 equal to mu2 up to mu k, like 3 groups will be mu3, right? So in that case, there are 2 applications we can apply the F test.